This video covers the relationship between voltage levels and electric fields. Let's say that we have electric field pointing in the positive x direction, and these are three different points within the electric field. If we place a positive charge at point A, it will take positive work to move it to point C. Therefore, C is at a higher voltage level. So we know that C is going to be at a high voltage level and B will be at a lower voltage level. So the voltage levels decrease as you move to the right. Let's explore how we know that C is at a higher voltage level. So this is our voltage difference equation. And we know that the work is positive to move this charge, so therefore the change in voltage is also going to be positive. If the change in voltage is positive, this means that the voltage at point C minus the voltage at point A is going to be positive as well. And this will only happen if the voltage at point C is greater than the voltage at point A. So we know that positive charges want to move with the electric field towards lower voltage levels, and negative charges want to move against the electric field to higher voltage levels. These two things are very, very important to remember, so make sure you write these down. Let's do an example. It takes 6 joules of work to move a 3 coulomb charge from R to S, and it takes 12 joules of work to move the same charge from S to T. We're going to choose R to be ground, so notice how I already wrote 0 volts next to point R. We want to calculate the voltage levels at S and T. So let's first calculate the voltage difference between R and S. We know that it takes 6 joules of work to move a 3 coulomb charge from R to S, and this gives us a voltage difference of 2 volts. So, since R is 0 volts, this means that point S will be 2 volts. So the difference between 0 and 2 is just going to be 2 volts. Now we can find the voltage difference between S and T. So it takes 12 joules of work to move the same 3 coulomb charge between S and T. So the voltage difference between S and T is 4 volts. So take note that this does not mean that point T is 4 volts. This means that the difference between point S and point T is 4 volts. And since point S is 2 volts, that means that point T must be 6 volts. Next, we want to calculate if a negative 4 coulomb charge is placed at point S, which point would it tend to move spontaneously? So we know that negative charges want to move towards higher voltage levels. So therefore, a negative charge, this negative 4 coulomb charge, will want to spontaneously move to point T since T has the highest voltage level. And lastly, what is the change in potential energy for a 2 coulomb charge to move from T to R? Alright, so we have our potential difference equation, or our voltage difference equation, and we know that work is equal to the change in potential energy. So our voltage difference equation can be simplified to this. We can change in the values, or put in the values for the change in potential energy and the charge, and we see that the change in potential energy is negative 12 joules. So notice that the potential energy decreases, or that the positive charge loses potential energy. Since positive charges want to go towards lower voltage levels, when the charge goes where it wants to go, it's going to lose potential energy.